Yes, Ahmed, how are you? Yes, Ahmed, Assalamu alaikum.
Assalam, sir.
How are you?
I'm good, sir.
All right. So today we are going to begin with the new chapter, right?
Yes, sir.
Okay, and that is quadrilateral.
What?
Okay, so that is the chapter we are going to begin with. Okay, let me remind you about the assignment. You haven't sent the assignment of chapter number 2, Ahmed.
Oh, yes,
Okay.
sir.
Yeah. Did you forget or did you forget to complete?
No, sir. I still have to complete it, sir.
Okay, okay. So after the class, send you assignments. Okay.
Mhm.
Okay. So it was of exercise 2.5 and 2.6. All right. Okay. Actually, yeah, have you received the assignment?
Which assignment?
Yeah. In chapter number 2, exercise 2.5 and 2.6. That was not sent to you in the
Oh,
form of the questions. Okay. So
yeah,
do
no,
one
sir.
thing.
Wrote
Send the solutions of exercise 2.5 and 2.6 on the given number. All right. So without wasting any time further, let's begin with the new chapter. So Ahmed, today we are going to begin with the new chapter. What is the name of the chapter?
uh, square, no, quadrilateral one.
Quadrilateral. That is the chapter. So the name of the chapter is Understanding Quadrilateral. Okay, give me a minute. So currently in your school, which chapter is going on in mathematics?
Chapter number 6, sir.
Chapter number 6. Have they
Mm,
skipped any chapter in between chapter 2 and 6?
no, sir.
Okay, okay. So chapter number 3, 4, and 5 has been already completed. Are you sure chapter 6 is going on?
Yes, sir. Chapter number 6, square and square root.
Okay, okay. So no chapter has been missed out.
Yes. No
All
chapter
right,
has
all.
been missed out.
Okay. By the way, your classes begin in which month? In school,
Yes.
your classes begin in which month in your school?
In like August or not August. Wait, sir.
Anyways, leave it. Okay. Yeah. So
April,
we are
sir.
going in the month of April.
4th. Yes, sir.
Okay, okay. All right. So we are going to start the new chapter, that is understanding quadrilaterals. All right.
Yes, sir.
Understanding quadrilaterals. Now, any idea what does the word quadrilateral mean here? What is the meaning of this word quadrilateral here? Yes, Ahmed?
Quadrilateral, the and shape which has 4 sides.
Which has 4 sides. That is called simply quadrilateral. Okay. So if we were to discuss, let's discuss a few things about the basics of shapes. All right. Like you see, if we talk about curve, in your previous classes, in your junior classes, you must have studied about curve. Curve, curve. What do we understand by this word curve?
Uh, we understand it's a
The
shape which is bent over.
it is bent over. But on
Yeah.
paper, if you draw a line, without without lifting your pencil on a with the help of a sharp pencil, if on a piece of paper you draw a line without lifting it, that is simply called curve. All right. So we basically say that a figure traced on a piece of paper using a sharp pencil without lifting the pencil is called a curve. Why did I say it?
Okay.
A figure drawn on a piece of paper using a sharp pencil or a pen without lifting the pencil, not lifting the pencil. That is called a figure. That is called a curve. All right. It's called a curve.
Okay.
Okay. Now, if we to talk about curve, now you have got an open curve and closed curve also. So what are
Yeah.
open curve? What is
Yes.
an open? What is an
Open
open curve? Yeah.
any shape which of the half is like uncompleted.
All right. So we basically mean that a figure that does not in at the starting point. Like if I draw figures like this,
Okay.
these are all examples of what?
Oh,
Open curve, right?
open cover.
Because they are not ending at their starting point, right? So these are all examples of open curve here, right, Ahmed? So a
Yes,
figure
sir.
that does not in at the starting point. All right,
Yes, sir.
is called an open curve. So similarly, we will be having closed curve also, right? So what can we say
Yes.
about closed curves?
Closed curve. We could say the shape is closed.
The shape is closed, right? So
Closed.
in the case of closed curve, the figure ends at the starting point, right? The figure ends at the
Yes, sir.
starting point. So a figure that ends at the starting point, that is I dot is, it means that is, so that is starting and ending point the same.
Oh,
Starting and end points are same. All right, Amit.
yes, sir.
So if curve figures look like this, on Fridays and Saturdays your schools are off, right?
Yes, sir.
All right. Okay. So if a open curve looks like, so closed curve will look like this, right?
Yes, sir.
It will look like this. These are all examples of closed curve, right? So
Yes,
after
sir.
closed curve, next thing we have is simple closed curve. Even in closed curve, you have got two varieties. One is a simple closed curve. Now, what do you understand by this? Simple closed curve. What does it mean
Simple
now?
closed. Simple closed curve. It's like a square, rectangle, triangle.
Simple closed curve. Look,
Oh, closed curve. Like
no, no, no.
circle. Then
A circle. Yeah, that is correct. That is an
yes, sir.
example of
Sir.
a simple closed curve. Look, basically,
And
those closed
here.
curves which do not intersect itself, right? If we draw a
Yes.
circle here, or if I draw a triangle here, and a square and a rectangle, all right, so they are not intersecting itself. But if I draw a figure like this figure is intersecting itself. Or if I draw a figure like
Yes, sir.
this, so that is intersecting itself. Or another figure like this. So these figures are intersecting itself. While the figures in the first line you see, these are not intersecting itself. So we say that those closed curves which do not intersect itself are called simple closed curve. Right, Ahmed?
Yes, sir.
Okay. We say that. What would be the definition? Those closed curves, that do not intersect itself are called what?
Are called polygon.
Are called simple closed curve. We are having discussion about simple closed curve, right? Why are you going to polygon right now?
Yes.
Okay, are called simple closed curve. Okay, for example, these are the figures which are simple closed curve. Okay, all right.
Yes, sir.
Okay, and similarly, we will be having non-simple closed curves also.
Yes, sir.
Non-simple closed curve. Now, what can you say about non-simple closed curve?
Non-simple closed curve.
The figures are given here. These are the figures of non-simple closed curves.
Oh, okay, sir.
So what we say that those closed curves that intersect itself are called non-simple closed curves. All right.
Sir.
So we say those simple closed curves that intersect themselves. All right.
Yes, sir.
Are called non-simple closed curve. All right. So these are all about basics, right? These are all about basics. Now we are going to talk about the figure having more than three sides. Okay, having three or more than three sides. Since a closed figure cannot be formed with just two lines. If we were to form figures using lines, you will require more than two lines. Let's say I give you two lines here. Okay, or let's say I give you two sticks here, and I told you to make a closed figure using these two sticks without breaking them. Is it possible?
Yes, sir.
No. Listen to my question carefully. I am giving you two sticks here. Okay. I am giving you two sticks here. And without breaking them, I asked you to make a figure here. Okay. Is it
Oh,
possible?
no,
Let's
sir.
say these are two sticks here in my hand. Okay. Can you see it? These are
Yes, sir, I
two
can.
sticks in my hand. So is it possible to make any figure using these two? No, it's practically impossible. Okay. Now, if I give you one more figure, one more stick here, a stick third, then is it possible to make a figure now?
Yes, sir. Triangle.
Yeah, triangle, right? So polygon is such a figure where you make use of where you make use of three or more than three lines to construct a figure. So we come to the concept of what? Polygons. All
Okay,
right.
sir. Okay.
So what are polygons? Polygons are closed curve figures. They are closed curve figures made up of three or more than 3 straight lines. All right. Now, can a circle be a polygon? Think of this while I'm writing the definition.
No, sir, circle cannot be a
Yeah,
polygon.
exactly. Figure that is made up of 3 or more than 3 lines, right? 3
Yes, sir.
straight lines, not curved lines. Straight lines are called polygons. Okay, and poly means here many. All right.
Yes, sir.
Okay. So if you were to talk about polygons, polygons are also of few different types. All right. So there is furthermore classification in polygons also. Like you see, there are concave polygon, there are convex polygon. All right. So
Yes,
one
sir.
type of polygon is concave polygon. All right. Another type of polygon is what? Convex polygon. Convex polygon. All right, Ahmed. And the another one is regular polygon. Remember the names. Regular polygon. And the fourth one is which one? Irregular polygon. All right.
Okay.
Irregular polygon. Now repeat after me. There are 4 types of polygon. There are 4 types of polygon.
Four
What are they?
types.
The names are written here.
Concave, convex, irregular, and irregular.
Yeah, regular polygon and irregular polygon. All right. Okay, now let's have a look at each of them. All right. So let's say if we talk about concave polygon, if I draw a figure like this, okay, that is a polygon here. All right. So these are its falling angles. Let's name this polygon here A, B, C, D, and E. Okay, that's how we name a polygon. Okay. Now see in this polygon, which is the greatest angle?
Greatest angle.
Yeah,
E.
angle E, right?
Yes,
And this angle E, or we can name it as angle AED. All right. If you
sir.
see, it is greater than 180 degree. It is greater than 180 degree. All right. So in a such type of polygon in which at least one of the angle is greater than 180 degree, such type of polygon is called a concave polygon. All right, Ahmed.
Okay, sir.
Such type
Yes,
of
sir.
polygon is called what?
Concave.
Okay, now tell me what is concave polygon?
Uh, a shape which has the shape type structure
Yeah,
and
a
has more
polygon
than
in which at least one angle is greater than 180 degree.
yes, sir.
I'm asking about concave polygon. So concave polygon, what do you understand by this? Yes, Ahmed. Look, a
Sir.
polygon in which one of the angle is more than 180 degree. All right. So that type of polygon is called concave polygon. Getting this?
Yes, sir.
Yes, Ahmed? All right, very good. Now, if you see convex polygon, what do you understand by convex polygon here? So if every angle of a given polygon is less than 180 degree, such type of polygon is called what? Convex polygon. So let's say we take another diagram here. Okay. So these are, let's say, its angles. Okay, PQRS. Okay, so in this polygon, we can say that each angle is less than 180 degree, right?
Yes, sir.
Because
Yes, sir. We can.
180 degrees, how does 180 degree look like? It looks like this. That is a 180 degree, right, Ahmed?
Yes, sir.
Okay,
Yes,
and
sir.
if
It
we
is.
make fractions of it, obviously the fractions are going to be smaller than the whole angle. All right. So such type of convex polygon in which every angle is lesser than 180 degree, that is called what? That is called a,
Convex
yes,
polygon.
Ahmed, convex polygon. That is called what? Convex polygon. Okay. Now do tell me, before this we talked about concave polygon. What is the difference between concave polygon and a convex polygon here?
A concave polygon has a cave-like structure, sir.
As no. Look, concave polygon will not necessarily look like this. It can be different. It could be of another
Oh,
shape also. So it has got nothing to do with the shape. It could look like this also. All right.
yes,
It
sir.
could look like this also. So don't pay attention to the figure. Figure could be different. So we say that in a polygon, in a concave polygon, one of the angle is greater than 180 degree. All right.
Yes, sir.
Greater than 180 degree. Okay. Now, what would you say about convex polygon? I already told you. Just
Yes,
pay
sir.
attention to the
Convex.
angles of this figure.
Yes, I am.
Yeah.
So,
Okay, go on.
in a in a convex, the angle are great
Lesser than
are
180 degree.
360 degree.
No,
Oh,
you
it
are not.
is in
You are
180.
talking about the sum of the angles. In a convex polygon, every angle is lesser than 180 degree. Okay. So we say that in a
Okay, sir.
convex polygon, every angle is lesser than 180 degree. All right. That's the thing about convex polygon. Okay. Now next is regular polygon. All right. So now in a regular polygon, what
Yes,
will
sir.
happen? Every angle and every side will be equal to each other. Like take the case of a square. If you see a square, isn't all the sides same in a square?
Yes, sir.
Yeah. Let's draw a better diagram here. If you see a square here, yeah, see this one. Are all the sides not same here?
They
A,
are, sir.
B, C, D, and the sum and the measurement of all the angles are also same. That is, all of them are of 90 degree. So we represent 90 degree like this. Okay. If this
Yes, sir.
angle formed by the sides are of 90 degree, we use it like this. Okay. We represent it like this. And other than 90 degree, the angle can be represented via a curve. You know this, right?
Yes, sir.
Okay, very good. So in a regular polygon, we say that all the angles and all the sides are equal.
Okay, sir.
In a regular polygon, all the angles and sides are same. All right, Ahmed. Now the name itself
Yes, sir.
defines itself. The name is defining itself here. That is irregular polygon. So what does an irregular polygon mean here? Like, see this figure here. Are all the sides same here, or do the angles appear to be same in this polygon?
No, 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 sir.
No, right? So such type of polygon in which neither the sides nor the angles are equal, that is simply called irregular polygon. All right, Ahmed.
Irregular.
Yeah,
Okay, sir.
similarly, you can have figures like this also. Yeah, that seems to be a regular one. Okay, just go on with this definition, with this figure only. So let's name them K, L, M, and we can name it anything. So the definition of irregular polygon is going to be what? Can you frame the definition?
Not all sides are equal.
And
And
not all angles are equal.
the oh, okay, so
Yeah.
not all angles are equal.
So in an irregular polygon, my writing is clear to you?
Yes,
You
sir.
can read it. Yeah. So in an irregular
Yes.
polygon, neither the sides nor the angles are equal.
Okay.
Okay. So an example of such an irregular polygon is a trapezium. Spell the word.
Trapezium.
Spell the word.
TR TRAPEZIUM.
Zium. So that is an example of a trapezium over here. The figure I have drawn here, that is example of a trapezium. All right.
Yes, sir.
Okay. So this is how a trapezium looks like. The two sides, this MN and KL, these two sides which I'm marking here, they are parallel to each other, right? They are parallel to each other. All right. And the sides, you know what is parallel? Like you see the tracks of
Yes, sir.
railway line, they never meet each other. If they meet each other, then the train will clash. The train will get off from the track. That is, derailment will happen. So in this figure, you see line MN and KL. These two lines. Let me mark it. Getting it? Which line I'm talking about? These two lines here.
MNNK.
Yeah. So they are running parallel to each other. And notice the other sides, KN and ML. They are not parallel to each other. If we draw it further, they will meet at a point like this. Right, Namit? So such a
Okay, sir.
figure in one pair of such a figure in one pair of line is parallel to each other, and the another one is non-parallel. So such a figure is called what? Trapezium. Got it? So remember this, it will be useful for you in future classes. Okay, so that is about the different types of polygon. All right. Now, what are the 4 different types of polygon which we just discussed?
We have discussed about concave, convex, regular, and irregular.
All right. What is the difference between a convex and a concave polygon?
The angle is lesser than 180 degree.
Lesser than 180 degree. In which one? Concave or convex?
Convex.
Convex, okay. Every angle is lesser than 180 degree. Okay, what about concave?
Yes, sir. It is
Okay,
bigger than 180.
at least one of the angle in a concave polygon is greater than 180 degree. All right. Okay, regular and irregular, you already know this now. Okay, now next thing we are going to talk about is how we classify these polygons, right? Based on their number of sides, how we classify them, how we name them. Like you must have heard about pentagon, hexagon, right? Triangles, squares. All right. So next thing we are going to be discussing about is the Classification of polygons.
Okay, sir.
Classification of polygons. Okay, so in this you see there are polygons. The minimum number of sides in a polygon can be how much?
What?
What is the minimum number of sides in a polygon?
Minimum number of sides in a polygon.
Yeah.
It is uh
It is three. It is three.
oh,
That is obvious. All right. Okay. So you see a figure having three sides, that is called as what? Triangle, right?
yes, that
Triangle.
over.
Okay. And figure will look something like this. Okay. Now, what about a figure with four sides? That will be called as quadrilateral. All right, Ahmed.
Yes, sir.
And the figure will be looking like this. It could be a square, it could be a rectangle, or it could be a figure like this. Okay. So that is example of quadrilateral. Quad means
What?
four and little means side here. Okay.
Yes, sir. Okay.
Now next, what about a
Mhm.
figure with five sides? That is going to be called as pentagon. Pentagon. Pent
Penta
means five here.
5.
Okay. Now the figure will look like this. All right. That is example of a pentagon here. All right. Now a figure with six sides, that will be called as hexagon. Hexagon. Hexa means six. All right. You can remember it like this. Tri means three, quad means four, pent means five, hex means seven, hex means six. All right.
Okay.
So a hexagon will look something like this: one, two, three, four, five, and six. This is example of a hexagon here. Okay. Now, what about a figure with seven sides? If you got a figure having seven sides, that would be called as heptagon. Heptagon. So hepta means here seven. All right.
Oh,
So figure
okay, sir.
will be looking like this: one, two, three, four, five, six, and seven. That is example of a heptagon here. Okay.
Okay.
And there can be figure having more than seven sides. That will be called as octagon. Octagon. Octa means eight here. So the
Octam
figure you
8.
can draw it like this. Yeah. One, two, three, four, five, six, seven, and eight. Okay. What are the sides? One, then two, this third one side, then fourth, five, six, seven, and eight. Let me mark it for you. This is the first side, then second, then third, fourth, five, six, seven, and eight. All right. So a figure having eight sides, that would be called as octagon. What about a figure having nine sides then? Yeah, that would be
A
called as
figure have
having nine
that
sides.
uh
That will be called as nonagon. All right,
no,
Ahmed.
yes.
And a figure having a 10 sides, that will be called as decagon. Decagon. Okay. Now repeat after me. A figure having three sides, that will be called as yes, Ahmed, are you there?
Yes, sir, I am.
Yeah, a figure having three sides will be called as triangle. It is written over here. You just have to read it. Yeah, Ahmed.
Sir, my Wi-Fi isn't very good today.
Yeah, could you hear me?
Yes, sir, I can. Now I can.
Yeah. A figure having four sides will be called as?
A figure called four sides are called as a square and a rectangle.
No, the classification that is
Oh,
called
quadrilateral.
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 Yeah, square and a rectangle and another figure, those are its example. Okay.
Yes,
A trapezium will also be an example of quadrilateral, right?
yes, sir.
Now, what about a figure having five sides will be called?
A figure
Having
penta
five sides, pentagon. What about six sides?
hexagon.
Hexagon. That will look something like this. Seven sides?
Seven sides are heptagon.
Heptagon. Very good. What about eight sides?
Octagon and
Octagon. And nine,
nonagon.
10,
Decagon.
decagon. All right. Very good. So remember that on the basis of sides, we have divided polygons into 10 groups. Okay, those are triangles, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. There can be more. Okay, so if we keep on increasing the sides, ultimately we will reach to a figure that will become a circle. All right. Like if you keep on increasing the number of sides, the figure will become more and more curvy, right, Ahmed?
Yes, sir.
So we will ultimately reach to a figure that will be circle. Okay.
Mm-hmm.
All right. Yes, sorry. Now let's talk about diagonals. Now, what do you understand by diagonals?
Diagonals are a shape or a line that is tilted.
The first thing is it is not a shape. All right, Ahmed.
Oh,
Like
yes, sir.
if I take few figures here, like this one or this figure. Okay. So if I draw a line between non-consecutive vertices here, you know what is vertex?
Vortex.
Yeah, what is vertex?
No, no, sir.
Like in the figure, let's say these two lines
Vortex. I,
are meeting at this point O.
yes,
Okay.
sir, I know vortex.
So the point where the two lines meet, that is called vertex. Okay, very good. So let's say I have a figure here, A, B, C, D figure here. So in this non-consecutive vertex are which one? These two. These two are the non-consecutive. Consecutive means continuous. लगातार हो जो. All right, Ahmed. And
Yes,
non-consecutive
sir.
means that does not have a common line. Like consecutives are which one? This one and this one here. This A and this D. These are consecutive. So diagonal is always drawn between non-consecutive, like the diagonal, like the vertex D and vertex B. If you draw a line between these two non-consecutive vertex, that is called a diagonal. Okay.
Okay, sir.
Similarly, in the next figure, let's name this first. Let's say this is figure KLMN. Okay. Now to draw diagonal in this figure, which vertex we have to choose? Like we can draw
Which
vertex
word?
from K to M, and the next one has to be drawn between
K L to N.
and to L. So that is diagonal. Okay, so diagonal is simply the line joining the non-consecutive vertex of a figure.
Okay, sir.
These are, you see, all the fundamental things which you are going to require while solving the questions in this chapter. Okay, so it is the the non-consecutive vertex of a closed simple figure.
Close. Okay.
Got it? So we can present like this. These are all examples of diagonals. All right. Okay.
Okay, sir.
Now moving on, next we have got angle sum properties of different polygons. Just now we discussed 10 polygons based on their sides, right? Which were they?
Which were they? Uh,
Triangles, quadrilaterals, pentagons, hexagons, heptagon, octagon, and nonagon and decagon. These were the polygons based on their sides, different polygons based on the classification of sides. So next thing is that, like if you see a triangle, the sum of the three angles of a triangle is how much?
the sum of a three triangle.
No. The sum of the angles of a triangle are.
The sum of a triangle are.
No,
Oh,
not triangle. The sum of the angles, Ahmed. You see, there are three angles, let's say.
angle.
Yeah. What is the sum of the three angles of a triangle?
What is the sum of a triangle of a triangle? I don't know, sir.
Okay. No, sure. You see, this is a closed example of a closed figure and it has got three angles. So angle is formed when two lines intersect each other, when two lines meet. Okay. So angle is being formed at their intersection. So these are its angle. And in a triangle, the sum of the three angles is equal to 180 degree. Remember this thing. Okay. So in a triangle, what is the sum of the three angles? If I were to name it, let's say 1, 2, 3. So angle 1 plus angle 2 plus angle 3 will give me sum of 180 degree. Okay.
One.
So let's say
Okay.
I give you a figure of a triangle here. Let's say this is a triangle here. And these are the angles. This one is X. Okay. This one is 40. And this one is 60 degree. Okay. So how do you find the third one here? Third angle, that is X. If I were to ask you, what is the value of X here in the given figure?
What is the value of x?
Yeah. So simply,
It would be, sir. Wait.
yeah,
180.
180.
180.
No, I'm specifically asking about X, not the sum of the three angles. Like X plus 40 degree plus 60 degree, that is going to give me 180 degree. Since we know that the sum of the three angles of a triangle is how much? It is 180 degree. So X plus 40 plus 60, that is 100.
X plus 40 plus 60. That is 100. Okay.
So X here equals to, in the previous chapter we solved these type of questions. What is the value
Yes,
of
sir.
X
We
here?
have 80.
80 degree. Okay. So the value of X here is going to be 80 degree. All right. So X
Yes,
here
sir.
is 80 degree. So you can clearly see now that 80 plus 60 plus 40 actually gives me 180 degree, right? That is true for
Yes,
this
sir.
question. Okay. So this is a basic thing that you need to know about. All right. So remember this thing.
Um.
Okay. Now, In the next class, I will be discussing about angle sum property. Okay, angle sum property. Like what I'm going to be discussing in the next class is that, let's say you have got, like in the case of triangle, you know that the angles, the sum of the three angles is 180 degree. What about another figure? What about a square? In that, you know, it is 360 degree. Okay. Then what about another figure which has got five sides, like pentagon? See here,
Yes.
like this pentagon here. How would we find the sum of all the angles in such type of questions? Or let's say I have got a figure hexagon here. There are six sides here. Then how will you find the sum of all the angles in this one? That is going to be a difficult task. If you were to just keep on adding the keep on adding all the angles, right, Ahmed?
Yes, sir.
Okay. So if the sides of the polygon increases, so the task of adding the sum of the so the task of finding the sum of the angle becomes difficult. So for that purpose, we have got angle sum property of polygon. Okay. Okay. We still have time. I think we can discuss that. So angle sum property. So far, what we have discussed, are you enjoying it? I mean, are you understanding the concepts?
Yes, sir.
Like these are very basic things, right? So angle sum property. So if you take example of this triangle here, so what happens in a triangle? How many sides are there? There are three, right?
Yes.
And what is the sum of angles?
The
Sum of
sum
these
of
three angles,
angles.
it is actually 180 degree. We just discussed that, no? 180 degree,
180
right,
degree.
Ahmed? Okay.
Yes,
Now
sir.
let's say I have got another figure which has got four sides. It has got how
Has
many
got
sides? Four sides.
four.
So that is the sum of the angles in a square is how much? 360
Jump
degree. So that
360.
360 degree can be written as 2 multiplied 180 degree equals to 360 degree. Any problem in this?
No, sir. Mm-mm.
No. So now we can also write it like this: 4 minus 2 multiplied 180 degree, right? That will also give me 360 degree, right? No issue in that.
Yes, sir.
Like you can check that also. 4 minus 2, that is 2. Then 2 multiplied 180 equals to 360. Okay. Now can I
Okay, sir.
take another figure now? Let's say I take a pentagon here. That is a pentagon having 5 sides here. So in this case, can I say that the sum is going to be like this: 5 minus 2 multiplied 180 degree.
Yes,
That
yes,
is,
sir. We could. We could.
yeah.
3 into 180 equals
Or
to
let's say
3.
it is going to be 3 multiplied 180 degree. That is going to give you 540 degree. So can we not write it like this: 5 minus 2 multiplied 180 degree, right, Ahmed? We could do that. Similarly, let's say we have another figure. Let's say we have another figure which has got 6 sides. That is called as, what do we call a figure with 6
6
sides?
figure hexagon.
Hexagon. Very good. All right. So this is your hexagon. So can we find it like this: 4 multiplied 180 degree equals to 720 degree? Or can we do it like this: 6 minus 2 multiplied 180 degree? Because 6 minus 2 is also going to give me 4 here, right, Ahmed?
Yes, sir.
So
It
like
is.
this, if we keep on moving further, if we keep on taking examples of other polygons, okay, we will observe a pattern here. Can you observe a pattern here that 4 minus 2 multiplied 180 degree and 5 minus 2 multiplied 180 degree, in or 6 minus 2 multiplied 180 degree. In all of this, you will observe a pattern there that it is actually this 4 here, this 5 here, and this one, this 4 here, this 5 here, and this 6 here. Are these not the sides of the polygon? Right? See, a square has got 4 sides, and here I have did it like this: 4 minus 2 multiplied 180. Okay, Ahmed?
Yes, sir.
A pentagon has got 5 sides, and here I have written like this: 5 minus 2 multiplied 180 gives me 540. And see a hexagon here: 6 minus 2 multiplied 180 degree gives me 6 minus 2 multiplied 180 degree gives me 720 degree.
Oh,
Got this thing or not? If you got this,
yes,
then
sir,
I will move ahead. No, very good.
Yes, sir, I have.
No.
I have.
So can we not find a general form here? Are we not seeing a form here that sum of sides of a polygon is equal to sides minus 2 multiplied 180 degree. You can check that also. Let's take an example of any given polygon. You name it.
Yes, sir.
Name any polygon.
Name any polygon as simple curved polygon.
Yeah. The 10 polygons which we discussed.
10 polygons with this? The shapes. The
Yeah,
name
the
of shapes.
Yeah.
Quadrilateral.
Quadrilateral.
Pentagon.
Okay,
Hexagon.
just one. Let's say quadrilateral. Here we saw that this is a quadrilateral. Okay. And the sum of the sides here is 360 degree. Right, Ahmed?
Yes, sir.
In a
Yes, sir.
quadrilateral, the sum of the sides is 360 degree. Now we derived a formula: sum of sides of a polygon equals to sides minus 2 multiplied 180 degree. So how much sides are there in a quadrilateral? How many sides are there in a quadrilateral? Ahmed?
Yes, sir.
या कहाँ चले जाते हो आप? How many sides are there in a quadrilateral?
Four.
4. So it is 4 minus 2. We are putting the value of sides here, that is 4. So 4 minus 2 multiplied 180 degree. So that is 2 multiplied 180 degree. Right. That is giving me 360 degree.
Yes, sir.
Right. So we see that the values are same here. We got 360 here by putting the value of side. And in this one also we saw that the sum of the angles is 360 degree. Right. So similarly, we can check that for a pentagon also here. By putting the value of sides in the formula, we will see that it is also equal to 540 degree. Like let's take example of a pentagon here.